Hello, welcome to the IPC Essentials. If you are watching this, it is probably because you need something to help you out to be able to get credit for the school year. And so in this Essentials video, we're going to be talking about motion. We're going to be talking about things like speed, acceleration, and trying to figure out how to do the distance and things like that. So let's go ahead and get started with motion. Okay, so I think probably the easiest way to look at motion is if we had a car. So let's assume that we were in a car. Here's our little car. We are leaving a house. So here's our house. Here's the house we live in. So we're going to leave the house and we're going to drive on the road and we're going to drive. Let's say that there's a stop sign here. We're going to have a stop sign. Here's our stop sign. And after the stop sign, there's a little curve around the corner over here. And you have a friend that lives over here. So you're going to visit your friend. And we can talk a lot about motion. We can say, what is the speed of the car? What is the acceleration of the car? How long did it take to get there? What's the distance between the two houses? So when we're looking at a car driving, or you getting in a car and driving to somebody else's house, there's lots of different things that you can look at, and that's what motion or physics is about. Is just trying to describe what's going on in every situation. So let's take a look at this. Let's say that the distance, the total distance from, we can call this A to B. So let's say that the total distance is 1,000 meters. We'll make these nice, easy, round numbers. So when we're talking about motion, distance is one of the big things that we want to talk about. Distance is just how far it is from one point to another point. So if you're driving in your car, the distance is how far you are away. There's another thing that we can talk about. We can talk about time. How long did it take for you to get there? How long did it take for you to get there? In science, we like to use seconds. And so let's say that, let's say they live right around the corner, so it doesn't take that long to get there. Maybe you're going to visit your friend on the way out of going to a store that's much further away. Let's say that you're going, you stop at the stop sign and you continue on. Let's say that it probably takes about 120 seconds. Let's say it takes 120 seconds for you to get there. So that's about 2 minutes, right around the corner. So we can say, how far was it? We can say how long it took to get from point A to point B. Okay. Another thing that we could talk about is speed, right? We could talk about how fast did it take for you to get there. So the speed at which you traveled. In other words, how fast were you, right? If we were trying to ask the question, how fast was that? Because time, we know the time. We could look at our watch and say, oh, the time is this. And we could say the distance from A to B is this. But if we wanted to figure out the speed can change, because the distance is never going to change, but the time is going to change, right? If you go faster, that means it takes less seconds. If you go slower, it's going to be more seconds. So your time can change, which is going to change your speed. And if we wanted to figure out speed, the way that we can do that is by taking the distance. So we can say speed is equal to the distance that you're traveling, I'm going to abbreviate, divided by the time that it took for you to get there. And so in this case, if we wanted to solve for that, the distance is 1,000 meters. The time that it took to get there was 120 seconds. So distance divided by time is how we solve for speed. Speed is distance divided by time. That's an important equation. It allows us to know how fast we were able to get from point A to point B. So if we were going to calculate this, we would simply say our distance of 1,000 meters divided by the time that it took you to get there, which is 120 seconds. And so you'll notice we get 8.33, we can call it meters per second. The meters is distance, The seconds is time, so it's meters per second. So look at that. So far, we have distance, we have time, we have speed. We know how fast that it took for you to go from here to here. Another thing that we can talk about is acceleration. So with acceleration, the definition of acceleration is this. It's a change in, really it's defined as a change in velocity. So when we're looking at that, acceleration can occur really in three different ways. So how can you get a change in velocity? Well, one way that we can do that is increase our speed. Right? Let's do this. Let's make it a 1 here. So one way we can do is make a change. So that's 1. A second way that we can get a change in velocity or have acceleration is if we decrease speed. That's one that we normally don't think of. When we think of acceleration, we typically think of increasing speed, of starting slow and then getting faster, 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 faster. That's what we think of when we think of acceleration. But really, it's when you have a change in velocity. So a change in velocity is speed, right? So if you increase speed, that's one that we know mostly. Right? We have acceleration, but it's also when you slow down because you're changing your speed when you slow down. Another way that you can have acceleration is, and not many people think about this, is when you change direction. So changing direction is also when you have acceleration, because acceleration doesn't mean you're speeding up, it means you're changing your velocity. So speed, either increasing or decreasing, and changing your direction. Okay? So any one of these three things will cause you to have acceleration. And if we look at the equation for acceleration, acceleration is equal to change in velocity divided by time, which is basically what our definition is. Really, the main point that I want you to get here is that if you increase speed, you decrease speed, or you change your direction, you're going to have acceleration. Okay? So let's take a look at this. If the car was moving, right, when you leave your house, you speed up. So you have to speed up because you were stopped. You speed up as you're traveling, and then as you get to the stop sign, what happens? You start to slow down. So we have acceleration as you speed up. We have acceleration, also known as deceleration, when we get to the stop sign and we stop. Right? So at the stop sign, we stop. And then when we leave the stop sign, we start to speed up. And then you get to your friend's house over here to go see him, and you start to slow down. So at all of these points here, when you're changing your speed, you have acceleration. Another way that you have acceleration is when you have a change in direction. So right here, we're accelerating because we are going around this curve. As we go around this curve, we are changing direction. So acceleration is occurring a lot. Acceleration occurs a lot. Another thing that we can talk about is momentum. Momentum is when you take, if we want to look at the equation, momentum, which is defined as P, because M is already used in another equation, is mass times velocity. So the car has mass, and if it moves, it will have momentum. So momentum is defined as the amount of mass in motion. So it's mass in motion. So as long as you're moving, you have momentum. So as the car is traveling from here to the stop sign, it has momentum. But at the stop sign, if you are stopped, your momentum would be 0. So let's look at that. Momentum is the mass times, if we put 0 in for the velocity because we're stopped at the stop sign, 0 times anything is going to give you 0. So at the stop sign, your momentum is 0. Momentum is not based on the mass, it's based on the speed at which you're traveling. So you could be the largest truck in the world. If you're not moving, you'll have 0 momentum. So you have to take into account the mass and you have to take into account the velocity. 0 velocity means 0 momentum. So if it was asked, what is your momentum at a stop sign? Your momentum at a stop sign is going to be 0. All right, and then another thing that we can look at is graphs. In physics, we like to look at a lot of graphs. So if we wanted to do a motion graph, we can look at speed of a car. So we can look at speed of a car. In a speed graph, our distance is going to go on the y-axis and our time is going to go on the x-axis. So it's a distance time graph and it's going to show us the speed of a car. So if we look at a line, the slope of a line, if we compared two lines, we call this A, we call this B. The greater the slope of the line, the greater the speed of the car. So we had two different cars, we had A and B. A has a greater slope, so A would have a greater speed. Okay? Because they're able to cover more distance in that same amount of time. Another thing that you can look at when we're looking at a graph is if we have a horizontal line. If we have a horizontal line, if you'll notice, let's say that this distance is at 10 meters. They're at 10 meters at this time. They're at 10 meters at this time. They're at 10 meters here. They're at 10 meters. So that means that during this horizontal time period, right, during this horizontal line right here, during this entire time from here to here, they're at 10 meters, which means that they have stopped. So when you see a horizontal line in a distance time graph, that means the car has stopped. Another thing that you could possibly have is a curved line. A curved line would look something like that. That means that the velocity is changing. It's curved. It's not a straight line like these are. It's a curved line. It's a changing line. And when we have a change in our speed, right, either increase or decrease, that means we're having acceleration. So acceleration is when you have a curved line. And that's really the big ideas behind motion. Understanding these will help you to understand motion a little bit more. Okay? So hopefully that helps you look at your activity, and then you can also be able to set up your assessment.